So this video is going over homework 7, problem 16 through 22, solving absolute value inequalities. So step 1, isolate the absolute value. Step 1 is already done. In this problem 16, it's already isolated. Step 2, look for a special case. So what has to happen for it to be a special case? So remember, if you have the distance is negative, it's going to be a special case. Or if this distance is 0, you're going to have a special case. So this particular problem is not a special case. So we can move on to step 3. Step 3 is to write the correct compound sentence. So in this particular problem, should we write a compound and, or should we write a compound or? Which one should it be? The fact that it is a greater than symbol means we should write an or. So we are not going to write an and in this problem. We're going to write a compound or. And remember why. This is how I teach my kids about it. You have to be, right? So this, just to understand why we're writing a compound or, I always say this once. This says you must be more than 17 units from 0. So to be more than 17 units from 0, you have to be outside, you have to be out to the left of negative 17 and out to the right of positive 17. So I'm going to go ahead and put that there for a second. So normally I wouldn't write this on my paper. I'm just doing it to help you understand. So to be more than 17 units from 0, you have to be out here. So we then have to write the compound or, because that's a compound or. So we have to say 2x plus 5, no absolute values, has to be to the left of negative 17. So you have to say less than negative 17. You must have the word or in your problem, and then 2x plus 5 must be to the right of positive 17. So greater than positive 17. Some of you are not saying to the left. You're not showing that we need to describe to the left of negative 17, so less than, and to the right of positive 17, so greater than. So some of you are not using the correct symbols to describe that. And then when you actually solve each of the equations. So we're going to subtract 5 from both sides. And then divide by 2. And that gives us x is less than negative 11. Got to bring down your or. That's part of your answer. You must have the or in this sentence too, sorry. You must have the or in that sentence. And a lot of people are leaving that out. That's part of the compound sentence. That's part of it. You must write that in that original sentence. And then when you solve the other one, we're going to subtract 5 and divide by 2. And that gives us x is greater than 6. So this is what you should box off as your final answer. And then you should graph that. So you should always graph your inequalities. So all the numbers that are less than negative 11 are here, or all the numbers that are greater than 6 are here. So that's your graphing answer and your final answer. And make sure you box off your final answer. So let's look at number 17. So number 17, again, step 1, isolate the absolute value. It's already isolated. Step 2, look for a special case. This is not a negative and it's not 0, so it's not a special case. Then step 3, write the correct compound sentence. Which compound sentence should we write? Should we write an and, or should we write an or, which is the correct compound sentence? You should have said it's an and that we need to write, because we want to be less than 10 units from 0. And if you are less than 10 units from 0, you must be between negative 10 and 10. And that is an and. So we want you to write that x minus 7 is between 10 and negative 10. We want you to write the between statement. We will not accept if you write x minus 7 is less than 10 and x minus 7 is greater than negative 10. While that's not wrong, we do not want you to separate it. We want you to use the between type and. So that is a between and. That is an implied and that's what our expectation is. And then you add 7, and that gives you -3. And then when you graph that, we're talking about all the numbers that are between 3 and 17. Okay, number 18. Remember, you can always pause and try a problem and then go from there. But on number 18, I noticed some people distributing. You cannot distribute with absolute values. You cannot distribute. We have to undo any operations that are to the outside of the absolute value. So we want to isolate by undoing any operations that are being done to the outside. If you're multiplying by -2, then shouldn't you divide both sides by a -2? And then doesn't that leave you the absolute value? And the fact that we divided or multiplied by a negative, don't we have to remember to use the reverse rule? And then remember, a negative divided by a negative is positive. We need to see that step 1. That is a critical step where the expectation is step 1 will be on your paper. After step 1 is done, then step 2 is to see if it is a special case. Is the distance negative or is it 0? No, so it's not a special case. So after step 1, we can check for special case. And then step 3 is to write the correct compound sentence. Should we write a compound and, or should we write a compound or for this problem? It is an and because it is less than, so we should write a compound and because you have to be less than 6 units from 0. That means that x divided by 4 plus 1 has to be between 6 and -6 if you're going to be less than 6 units from 0. Or you can be on 6, right? And then you actually solve that compound sentence by subtracting 1 in the middle and to the ends. And then multiply by 4. That's how you show multiplying by 4. Maybe put a times 4 there. And that gives us -28 is less than or equal to x is less than or equal to 20. And then when you graph that, all the numbers between -28, make sure you're showing the solid circles and make sure you're showing just shading between. Don't go like this and like that. That's not correct. Do not do that. Shade the actual solutions and only shade the solutions. Number 19. Step 1, isolate the absolute value. That means to undo any operations that are outside the absolute value. So since we have a +8, we need to subtract 8. And that gives us the absolute value of 5x minus 3. Here is step 1. Step 1 has to be on your paper. That is a critical step. Then step 2 is to look for special cases. That is not a positive or negative. It's not a negative or 0, so it's not special. So then we have to write the correct compound sentence. Should we write a compound and, or should we write a compound or for this problem? Since it has to be more than 2 units from 0, that means it has to be on the outside of 2 and -2, so you should be writing a compound or, because it's a great TOR symbol, so we should be writing a compound or symbol. So again, if you are more than 2 units from 0, don't you have to be out here or on -2? Don't you have to be out here? So again, the compound sentence is 5x minus 3 has to be to the left, so it has to be less than -2, or as part of your answer, or 5x minus 3 has to be to the right or greater than +2. And then remember they said or equal to, so or equal to. So that is the correct compound sentence. So this is the correct compound sentence. We are seeing a lot of people they're not having a less than symbol go with the -2, right? To the left of -2. So you're messing up. Here's where your error is usually at. That's where we're seeing a lot of the errors, right here. So you need to make sure that your compound sentence is actually written correctly. Then we can go and start solving it. Got to have or in your answer. And try to have your final answer all on one straight line and box it off or highlight it so it's easy for us to read where your answer is. And again, you should have a graph that goes with it. So we're talking about all the numbers that are equal to or less than 1/5. All the numbers are equal to 1 or greater than 1. So that's what your graph should look like. Make sure that you have open circles and closed circles, and that it's clearly easy to read. Number 20, isolate the absolute value by undoing any operation that's outside the absolute value. So we have to subtract 4. And that gives us the absolute value of 2x is greater than or equal to -3. And this is step 1. So step 1 must be done first before you can do step 2. Step 1 has to be on your paper. Step 2 is to look for special cases. And don't we have a negative distance? So isn't this a special case? So we're going to use sign analysis to find out if it's all real numbers or no solution. When you take the absolute value of any number, no matter what it is, it's always going to come out positive. And is a positive number greater than or equal to a negative number? Is that always true, sometimes true, or never true? Isn't a positive always bigger than a negative number? So isn't that always true? So no matter what number you put inside of x, that's going to make a true sentence every single time. But you should always check 0 as well. What if we put the absolute value of 0 in there? Well, the absolute value of 0 is 0. So is 0 bigger than or equal to a negative number? Isn't that always true as well? Isn't that always greater than? So in this situation, no matter what you put in here, it's going to come out positive. So that's always going to be true. And if you make this 0 inside, that's always true. So your final answer is x is an element of the real numbers. And you can write x such that x is an element of the real numbers. Either one of these is fine. The second one is the more sophisticated one, or you can technically even write all real numbers. But you might have a teacher that says, no, I want you to use the notation, right? We're trying to get you up into the Algebra 2 section. So we want you to start using the fancier notation. This is read such that. So x such that x isn't, so this is such that. So this is x such that x is an element of real numbers. That means x can be any real number and it'll make a true sentence. Okay, number 12. Number 12, again, you have to undo any operations that are outside. So you have to undo adding 12 by subtracting 12 first. Don't forget there's a negative out in front of that absolute value. And remember, that's really a -1 being multiplied, so we got to divide out that -1. You can't distribute it. You cannot distribute it. You got to divide it out. So x plus 6. And since we divided by a negative, don't we have to reverse? So now isn't step 1 done? Step 2, check to see if it's a special case. It's not positive, it's not 0 or negative, so it's not a special case. So then we have to write the correct compound sentence. Should we write a compound and, or should we write a compound or? We're going to write a compound and because it is a less than, so we're going to write a compound and. So that means you have to be less than 4 units from 0. So that means x plus 6 has to be between 4 and -4. So you must write the between type sentence, the between and. And then you solve that between and. and then you graph. All the numbers that are between, that are less than -2, but also and it's greater than -10. Make sure your your dots are solid. Okay, number 22. 22, isolate the absolute value. So we have to subtract 5 from both sides. And that leaves us absolute value. Some of you are leaving out your absolute value bars. Greater than or equal to 0. And that's your step 1, is to isolate. So we subtracted 5 to both sides to isolate the absolute value. And then what is step 2? Look for special cases. To be a special case is when you have a negative or 0. So because we have 0, this is a special case. So we're going to do sign analysis. So this is a special case. So we have to figure out, is it a no solution type problem, or is it an all real numbers type problem? Which one is it? So we have to use sign analysis. When you take the absolute value of any number, so no matter what's inside of here, it's always going to come out to be positive. Is a positive greater than or equal to 0? Is that true? Is that always true or sometimes true? A positive number is always going to be greater than 0, so that is always true. But don't forget, you should always test for 0 as well. What if we have 0 inside the absolute value? The absolute value of 0 is 0. Is 0 bigger than 0? No. But is it equal to 0? So it's not greater than 0, but it is equal to 0. So that will always be true. So since both of these situations are always true, your final answer is that x is an element of the real numbers. So if you want to write x such that x is an element of the real numbers, if you just want to write real numbers, or if you just want to write it as x is an element of the real numbers. Either one of those is okay, but make sure your teacher might want you to write it this way. So I'm okay with either way, but we really should be writing it using fancier set notation. So those are your problems. What about 23? 23, isolate the absolute value. It's isolated. Step 2, look for a special case. A special case is when you have a negative distance or 0. So because we have a negative distance, we have a special case. So we're going to use sign analysis. So the absolute value of any number is always going to be positive. Isn't positive less than a negative number? Is that true? No, a positive number is not, right? That is not true. That is never true. That is false. What about 0? Is 0 less than a negative number? That is false as well. Therefore, since both situations are false, that means no solution. That's it for problem 16 through 23.